Today we're going to talk about permutations and combinations, and kind of the interesting thing is, if you know, like on your lockers that you have here at Hopkins High School, they have what they call a combination locker, or if you have your gym locker, that kind of thing. And the truth is, it's a misnomer, which means it's not called correctly. Because when you do a combination means any order you want to. So like if I'm trying to pick numbers in order, your locker combination is 12, 36, 7. I can pick any of those three numbers and do it in any order, and it opens your locker. So that's not true. What's true is you have to go in a certain order and in a certain direction. That's actually called a permutation, which means the arrangement of the numbers is important. So the first vocabulary thing that we're going to talk about is a permutation, which is the number of ways to organize, or in other words, choose from a group. And the big important thing here is that the order matters. There's a formula for that I'm going to show you on your calculator and in our notes, how to do it by hand in case your calculator runs out. And the symbology for that is N subscript capital P little r subscript, which means that you're taking the N factorial and then you're dividing which means you're dividing by the n minus r, parentheses, factorial. Or in other words, you're taking the total factorial, we'll talk about what that means, divided by whatever was left out, factorial. An example of this might be choose 2 students.
Good morning, Hopkins.
So choose 2 students out of 20. The first chosen gets an A. The second, an F. The way that you would write this down is you would say that that is 20 P 2. Or in other words, 20 factorial divided by whatever is left over, which would be 18 factorial. Now we can do this on our calculators. So if you go to your calculator and you type in 20 after you type in the 20, I think the next place that you go will be the math button on the far left. And then arrow over to probability, PRB. And you'll see that the second thing there is NPR. So you arrow down to NPR, hit enter, and then a 2. So this is saying use the P thing for probability, and then hit enter. And you'll see that it's 380. So then I go back down to my notes and I write down 380. And this is an example when you're choosing 2 students and the order matters, because whoever you chose first gets the A and whoever you chose second got the F, which is different than the first person got the F and the second person got the A. Whenever it matters that you do it in a certain order, you use the P button. So in the factorial down below in the example, what's really going on just for your information, in case your calculator ever runs out, is that NPR thing is really going 20 factorial divided by 20 minus 2, which was the number of people you were choosing factorial, and that's 20 factorial over 18, which was the number that was left out. And so as we wrote on the board, that's 20 times 19 times 18 times 17, and it keeps on going until it gets to 1. And then down below, you'll see the 18 times 17 times, and it keeps on going until it gets to 1. And everything on the top and the bottom from 18 down cancel out. And so what you end up with, of course, is the 20 times the 19, which is how we got the 380. So combinations is very similar to permutations. The only difference is in combinations, the order does not matter. So if I'm going to select two people at random and I don't care what order I take them in, and then I give them a B, for example, two people are going to get a B, and I don't care which order I pick them in, then you use combinations. So this is used to count ways to choose from a group when order does not matter. And the way that we symbolize that is we say we have little n, which is the number of people we can choose from, capital C, little r, which is the number of people we're choosing or things that we're choosing. And the way that you would write this in symbols is n factorial over r factorial and n minus r factorial. And what you can see is the only thing that's different is in the denominator, the bottom of the fraction, we're also dividing by the r, which is how many you chose factorial. And that's what's taking away the different arrangements of the things that you're selecting. So in words, what that means is the total factorial divided by the chosen factorial and times the left out factorial. So the only thing we've added in is the chosen on the bottom, which we did not have before. Let's look at an example of how this would work. Let's say that we're forming a committee of 4 people out of our class of, I don't know, roughly 27. And we want to know how many different committees can there be? That's the question. So as we look at this, I can pick any 4 people. So if I pick, for example, Shirley, Mai, Caleb, and Khadijah, I don't really care what order I selected them in. Those are the 4 people on the committee. Whether I picked Shirley first or I picked Caleb first, doesn't matter. They are the 4. If I'm doing that, the way that I would write that in symbols is I would say that I'm taking 27, capital C, 4. And the way that I would write that in numbers is I would have 27 factorial divided by 4 factorial times 23 factorial. And again, we can do this on our calculator. So the 27C4, if you have your calculator, it's very easy to do. We go to our calculator and we type in, like we did before, 27 as the starting place. This time when we go to math and look at probability, you'll see that not the second thing, but the third thing has a capital C. So we arrow down to the capital C, and we hit enter. And then we type in a 4, because we want 4 people out of those 27. And we hit enter. And this is how many different committees we could have possible if we're choosing 4 people to be on the committee. 17,550. So the answer is 17,550 different committees. Now, kind of the whole idea behind the stuff that we've been doing is that we're working with this thing called factorial. And factorial is talking about when you have something called n factorial. That means that you're taking the n thing that you see, like in the previous example, 27 maybe, and you take 1 off each time. So n minus 1, so 27 minus 1 is 26, times the next one, which would be 2 less than the original, so take away 2, then take away 3, then take away 4, and you keep on going until you get to 1. So the example we just got done with, if we were looking at it, means if I look at 27 factorial, for example, that'd be 27 times, take away 1 from that 27, that's the 26, and then take away 2 from the original 27, that's 25, take away 3 from the original 27, that's the 24, and you keep on going until you get to 1. That's what factorial means. It's a symbol in mathematics that's indicating a certain process. An example of how they might write a question to deal with this factorial would be something like the following. Let's arrange 7 people to line up. This means that we would have 7 factorial, which is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. And then you would take your calculator, and actually on your calculator, the cool thing again is you don't actually have to do that by hand if you don't want to. On your calculator, you can just type in a 7. And under the math, I believe, you can go to probability again. And you'll notice that number 4 has that exclamation mark, which indicates factorial. And you hit enter twice. And that's 5,040 different ways to organize 7 people. So then I go back and I write down as my answer 5,040. The biggest idea today is that we're going to be using these factorial things, but our calculator does it for us. So I want you to put at the very top, important note, use P when order matters. That's the most important thing. If order does not matter, use the C, which is combinations. If order matters, use P, which stands for permutations. We're going to organize them in a certain order. So now we have a bunch of examples that are going to show us how to use some of these things we just talked about. The first one says that there are 7 flute players